Good morning, everybody. This is the event of Critical View of Evidence-Based Medicine promoted by our Master and PhD of Public Health of Bahiana School of Medicine and in collaboration with our Center of Evidence-Based Medicine. We will have about 2 hours of interaction and talk and discussion about the interface between science and medical care. The interface between our medical cognition and our personal irrationalities. We're going to discuss how to evolve medicine. We have two types of technologies in medicine. The hard technology of the MRI, procedures, drugs, vaccines, and also we have the soft technologies of the thinking. And I believe thinking is the most important technology for medical care, both in the systemic standpoint and also in the individual standpoint or clinical standpoint. So we have to discuss deeper how to think about the medical system and about the care of individual patients. And for the celebration of the 20th anniversary of our graduation program in public health, medical, and health, we decided to do this webinar. And this webinar will be an interaction between us and people who are seeing us and watching us in the YouTube channel. You can put your observations, comments, questions. We'll bring you to our discussion. And I have the great pleasure to have here with me two special thinkers in medicine. And I'm grateful to be friends with them and to have them as partners intellectual partners in terms of thinking medicine. And I will start presenting them. We have here first Robert Kaplan, who is Associate Professor at Stanford University, Research Director at Clinical Excellence Research Center in Stanford. And I have to speak a little bit about Bob. So I know he's very known. Many people know him, but I want to speak a little bit about my view about him. Bob is a healthcare thinker, one of the most important, in my opinion, healthcare thinkers in the world. He's a distinguished professor. He has 20 books, more than 500 articles. And he's now a faculty member at the Clinical Excellence Research Center. Listen to the title of this research center, Clinical Excellence. And we have to discuss here what is excellent medical care. And this Clinical Excellence Research Center is at the Stanford University School of Medicine. But it has a very interesting, very important history of contribution to medical care in the US. Under the Obama administration, for example, Bob has served as the Chief Science Officer at the US Agency for Healthcare Research and Quality, what we know as AHRQ, and Associate Director at the National Institute of Health, where he led the behavioral and social sciences programs. But before that, he has been a distinguished professor at the UCLA, and he led the UCLA Health Service Training Program and Prevention Research Center. And also, before, he has been the chair of the Department of Family and Preventive Medicine at the University of California. So, Bob is, as I show you by his history, there's much more than that, but he has contributed a lot in terms of thinking how the health system should organize itself in terms to provide the best medicine. So this is Bob, and he will speak about evidence. he'll get a specific thing, and from the specific, we'll talk generally about healthcare. And his lecture will be evidence for approval of new drugs by the US FDA. Then we have John Mandrola. John Mandrola, like myself, he's a cardiologist. I am not interventional cardiologist, actually. He is an interventionist cardiologist because he does electrophysiology, ablation, and these kind of things. But he has a very peculiar way of doing this. He has a critical view about overuse of the very procedures he does every day. So this is very rare. Usually we have like what Kahneman mentions, like a skill bias. If you have the skill, you overestimate the way you see the value of that procedure. But John has the ability to give the adequate value to his procedure. He talks about overuse, and he does very good the procedures for those who really need. And John became, in the field of cardiology, a very important voice because he was very smart in terms of reading between the lines of evidence. He analyzes very brightly about bias and the value of every evidence and how it should influence how the cardiologists think and decide. So John is the editor of the podcast This Week in Cardiology. He's a Medscape columnist, very important and known Medscape columnist. He's very active as a with his scientific thinking in Twitter. He has 22,000 followers in Twitter. He's like a Kardashian in the good sense, right? So everybody wants to know John's opinion on new evidence and things like this. So as you can see, we have two people here who can contribute a lot, and each one of them will give a short lecture of 20 to 30 minutes, and then we will start a discussion. And in the program, it looks like I'll have a lecture myself, but I won't have a lecture. The name of my lecture in the program is Irrationalities of Medical Cognition, but it's not going to be a lecture. It's going to be the way I will moderate this discussion, okay? So now we will start with John Mandrola. John, now you can share your slides and start your talk. And thank you very much, both of you, for being here. Okay.
Well, thank you very much, Luis.
We already are. Your talk is already on the screen, so you can start anytime.
Okay. Can you hear me okay?
Yes.
All right. I'm going to talk about Luis. I'm getting a bit of echo. So let me see.
Okay, you're getting.
Okay. I think it's better now.
Okay, yes. We don't have echo here. Your sound
okay, good.
Okay.
Okay, sorry for the confusion. So thank you for having me. It's a real honor. I'm going to talk about scientific bias in cardiology. And I don't have any financial disclosures, but people would say I have plenty of biases. I'm going to make the case for a conservative approach to medicine and for being skeptical to try and avoid hubris. So this is what my goal is in this talk. And when you ask me to talk about bias, I looked up bias, and my gosh, there's blue million biases. I think the best one is just a simple definition: the inclination to present or hold a partial perspective at the expense of other possibly equal or more valid alternatives. In cardiology, I'm a little bit torn because, look, we've been a leader in generating evidence, but there's a lot of evidence that has to be translated, which is hard. But even so, here's a study of last year looking at our guidelines, 2,600 recommendations in our guidelines. And if I was giving this talk there, I'd ask what you thought, what the evidence was, or how strong. And look, less than a quarter of guideline-directed practice is backed by strong evidence. And so most of the things that we recommend in guidelines don't have strong backing. Now, I want to set the stage for bias and so-called Bayesian priors. And I think the first Bayesian prior that we always have to remember is that true progress is very hard. I took this picture from Twitter because it's the metabolic pathways in the cell, and you can just see this visual representation of how complex we are as a human body. The so-called magic bullets are very rare. I mean, things like antibiotics and insulin and pacemakers, these childhood vaccines, these are very, very rare magic bullets. But even magic bullets pale in comparison to simple sanitation and the relief of overcrowding. I borrowed this slide from Rograd, Saurabh Jha, and it shows how the mortality from tuberculosis was decreasing years before there was any kind of drug for it. So second Bayesian prior, before you even start, is that we all have human life has a clock. I love this paper from James Fries on aging and natural death. And if you look, if you make it to age 75, your chance of life expectancy hasn't really changed much from the year 1900 and 1980. I mean, most of the gains we make is in childhood illnesses. And you would say, well, we're doing better since 1980, but look at these life curves from CDC. Again, since 2006, digital revolution, life expectancy is flat. A third Bayesian prior is the intensity and immensity of uncertainty. So a few years ago, clinical evidence experts from the BMJ studied 3,000 treatments that we do, and they found that only 11% are definitely beneficial. Over half of what we do is of unknown effectiveness. Again, humility. And of course, medicine changes. No better paper than that is from Vinay Prasad's group on medical reversals, where a trial shows that an accepted practice is not better than a prior lesser standard. This was a huge project of looking at 3,000 trials from Lancet, JAMA, New England. And they found that more than 1 in 10 of the randomized controlled trials reversed an accepted practice. And some of these were even codified in guidelines. And guess which field of medicine had the most reversals? Cardiology. And we have, I think, the king of all reversals in the CAST trial in 1991. And when I started medical training, we were scared of PVCs after myocardial infarction, and so we had drugs that would suppress them, enconide and flecainide. And the idea was that if you suppress the PVCs, you'll make people live longer. And when this idea was tested in the trial, we found that no, we were actually killing people. 3.5% absolute risk increase. A number needed to harm of 29 patients. Completely reversed a standard. Hormone replacement therapy to prevent cardiovascular events was a super common thing to do back at the turn of the century. Then the Women's Health Initiative came and showed that there were increases in coronary events, strokes, PEs, and breast cancer. Again, a huge reversal. Even statins, my friends. I am not a statin denialist, but this can be tricky. So the GC heart failure trial and Corona trial studied patients with heart failure of any cause, even ischemic heart failure, and found that statins in heart failure patients did not improve outcomes. Same thing with chronic kidney disease, end-stage kidney disease on dialysis. We see a ton of patients like that on statins. And again, 2 large randomized trials, no difference in outcomes. So why are we susceptible to these reversals? And let me tell you about publication bias. And Louis, I have to thank you for asking me to give this talk, because when I looked into this, I found some really interesting things. So it was first described as the file drawer problem by Dr. Robert Rosenthal. And he said that journals are filled with 5% of the studies that show type 1 errors, false positives, but file drawers are filled with 95% of the studies that show non-significant results. And you know, 2 editors of JACC have written about this. William Parmley and Tony DeMaria. And I took this beautiful quote from William Parmley, who's so candid. When faced with a negative or statistically insignificant study, it is difficult to accept while turning down other positive studies. Now, one of the best illustrations of this was a paper by John Unity's group in 2016. They looked at 16 million abstracts from Medline and PubMed, and they found, get this, 96% of the biomedical literature has a study which has a positive p-value in it. So I think Dr. Rosenthal was correct. But the thing is, publication bias is pretty hard to detect. Here's a paper from 2013 looking at whether there's bias in biomarker studies. So we all use biomarkers, BNP, et cetera, CRP, and they looked at 56 meta-analysis. Okay, they found 88% had statistically significant results. But they found that more than 1 in 10 had high levels of heterogeneity, which decreased confidence in a meta-analysis. 23% had small study effects, and over half had an excess of studies with significant results expected. And only 13 of these meta-analyses had statistically significant meta-analysis had no hints of any of these issues. And a good example is the meta-analysis on ApoB. Again, I squared is heterogeneity. 80%, and anything really over 50% decreases one's confidence in a meta-analysis. And look at the small study effects. So the summary rate ratio is almost 2, but the rate ratio in the largest study is 1.32. So again, small studies driving these meta-analysis. But predicted significant versus observed significant, there's more observed significant than you would think. So one of the best examples of this is rosiglitazone, or Avandia. And this was a popular drug for diabetes. It was approved on the basis of the surrogate marker of glycemic effects, and it rose to sales of $3.3 billion annually until Dr. Nissen and Kathy Wolski did a meta-analysis to evaluate the cardiac effects of this drug. And it shocked the world of diabetes when they found that this common drug increased the rate of MI by 43% and CV death almost statistically significant. And how did this happen? Well, these are on the right part of the slide are the studies that they used, that Nissen used. But get this, 35 of the 42 trials conducted by the drug maker were unpublished, and they were only available after a lawsuit by the state of New York. Not a lawsuit for this, but a lawsuit for something else, but it allowed public disclosure of these unpublished trials that are in the file drawer. And what Nissen found is that the 2 randomized trials, DREAM and ADOPT, they really didn't show a statistically significant increase in cardiac events. But when you combined the unpublished small trials, then you started seeing more events, and this drove a positive p-value for MI and almost significance in cardiovascular death. So it was the unpublished data that really drove the findings of this meta-analysis. Now, it's fair. I want to be fair. This paper was widely criticized. Sanjay Kaul has problems with it, and he would point that there's been another trial of rosiglitazone, the record trial, which was null for cardiovascular death. But again, this record trial, if you look into it, has a lot of internal validity issues. I think the most important one is that it was underpowered because of the small number of events. But rosiglitazone is an important thing to study because even before Nissen's paper in 2007, the makers of this had a meta-analysis that found very similar things, but FDA and GSK agreed not to publicize these risks. FDA conducted its own meta-analysis and confirmed the MI signal. They voted 20-3 that this drug increases cardiovascular risk in 2007. And this is actually where the whole mandate for CV outcomes trials for type 2 diabetes comes from. And the GSK pled guilty to criminal misconduct and paid a large fine. So I would ask, would any of this have been discovered without the unpublished data? Would we even have discovered SGLT2 inhibitors without the Nissen meta-analysis? Now, here's a story about therapeutic fashion. what we like to do, and when therapeutic fashion meets publication bias. And it's another historical study that I discovered, thanks to you, Lewis, for putting me onto this talk, of lorcainide, which rhymes with enconide. Lorcainide is a type 1C antiarrhythmic drug. It suppresses PVCs. Now, remember I told you about CAS was 1991. Well, years before, Professor Rodney Hampton did a study about these antiarrhythmic drugs. He introduced his study by describing the fashion, which was to reduce warning PVCs with antiarrhythmic drugs. So in 1980, they did a study at their center of lorcainide, and it was powered to show a decrease in PVCs. Death was not a primary endpoint. But what they found in 1980, a decade before CAST, was that this drug did reduce ventricular arrhythmias. But look what happened. 18% died in the lorcainide group, 2% in the placebo group. So they expected the 10% death rate, and they were fair. This outcome was not pre-specified, and so it could have been due to the play of chance. But no journal would publish this study. So they tried and lost interest, and then the makers of the lorcainide stopped making the drug. But then a few years later, more meta-analysis came out showing antiarrhythmic drugs increased death after MI. Now, Dr. Hampton and his colleagues got this paper published, but look at the date, 1993. And they wrote in this paper that the moral of the story is that evidence-based medicine depends on evidence that has been collected according to the fashion of the day. And it depends on what can be funded and what interests journal editors and reviewers. And this, too, is often a matter of fashion. An important story. Okay, what about outcome reporting bias and spin? Here's an example we all know about: absolute risk reduction versus relative risk reduction and p-values. And the best study I found to show this is the Tyrex patch. This is a Tyrex envelope. This is an envelope that we put around devices to reduce the risk of infection. And this was studied in a large randomized controlled trial called RAPID, 7,000 patients, Tyrex envelope versus control with a legit primary endpoint, serious infection. And what they found is that there was a relative risk reduction of 40%. And it went from 64% reduction to 2%, the confidence intervals. But the absolute risk reduction, only 0.5%. So if you use the NNT, and NNT is not perfect, but the point estimate of the NNT is 200. But the upper limit would be you'd have to treat over 4,000 patients with this to prevent one device infection. And this Tyrex envelope cost $1,000 per. So it's $200,000 to prevent one device infection. And if you use the upper limit of normal, it could be up to 4 million. So again, you can be biased by relative risk reductions. You can also be biased by spin. And here's a paper that I was involved with and I'm pretty proud of. This was a nice, really a nice paper. I liked it. I was glad they asked me to be part of it. This was a review of 6 major journals over 3 years. And we looked at trials that had a non-significant primary endpoint. And we found that of 587 studies, 16% had non-significant results. And we were looking for spin, which is language designed to distract from the non-significant primary endpoint. And an example would be if you were emphasizing a secondary outcome or a subgroup in a trial with no non-significant results. Get this, we found that its spin is in 57% of abstracts in these journals, 67% of the main paper, and even 1 in 10 had evidence of spin in the title. Reporting of harms, everything that we do has potential harm. Another paper I was involved with, a similar sort of methodology, looking at CIRC, European Heart, JACC. We found 153 RCTs in this 6-year period, and we looked at the consort standards for reporting trials and found that 40% of these papers did not adhere completely to the consort harm checklist. And we found that no improvement was noted over the 6-year period. People are more interested in presenting benefits than harms. Reproducibility and transparency. Okay. This is another remarkable paper. What about if you publish a paper and then you reanalyze it at the same data? So here's a paper looking at 37 trials that were reanalyzed and 32 by the same authors. And they found, shockingly, that 1/3 of these papers, reanalyses, led to interpretations that were different from the original article. And up to 1 in 4 more patients should be treated, and it really changed things. Same authors. This is probably the most influential paper that I've read in a decade. I think it's so important. This is Brian Nosek's group, and they're interested in open data. They published this paper. I wrote about it on Medscape. They asked a simple question, and they recruited 29 teams of data scientists. These were all academic teams. And they had one data set from Europe, and they wanted to answer one question. It's a social science question, but it could be any question. Are soccer referees more likely to give red cards to dark-skinned players? And so the 29 different groups used all of these different analytic techniques, which I don't really understand, but they're different. And look what happened. 2/3 of the analysis of the same data were significant. 1/3 was non-significant. And so, ladies and gentlemen, I would say that this is an important paper to think about every time you read an observational study set taken from a large data set. Because when you read a paper, you read one statistical analysis of that. But when you think about the Nosek paper, if you analyze it a different way, would you have got a different result? Then, of course, competing interest. And competing interest is best described by Stark's stages of conflict of interest and motivated bias. And in a beautiful paper written by Dr. Goldberg, which I'll show again, he talks about 3 stages: an antecedent act, being asked to be on a guideline panel, dinner, a talk, whatever. And that is an antecedent act that leads to a state of mind which could then cause a behavior of partiality. And they're very clear that not all antecedent acts leads to behaviors of partiality. But Stark was clear that there was no such thing as potential conflicts of interest. If there's an antecedent act, there is an actual conflict. And he found that this was important because these disclosure slides that you see at meetings, cannot break this cycle. And in fact, some empirical data would suggest it can intensify behaviors of partiality. So what's an example of a duality of interest? Well, there's some in rosiglitazone. After this thing came out, 3 years later, after the meta-analysis, a group published they reviewed 202 articles on rosiglitazone and found that 45% of the authors had conflicts of interest. And, of course, authors with favorable views of the drug were more likely to have financial relationships with the makers of the drug than authors with unfavorable views, and the rate was 4.29, 4 times more likely. How about guidelines? Dualities of interest in the guidelines. So here's a paper looking at 45 guidelines from 14 specialties. Half the authors had conflicts, but only 2% of the guidelines disclose these fully. And you say, oh, well, that paper is from 2013. But here's a paper from last year in Circ Outcomes, looking at the relationship between what the author discloses and what the companies disclose. And you can see companies disclose that 75% of authors have conflicts. Authors disclose only 16%, and the agreement between those is less than 10%. So again, I'm not sure we're doing that much better with disclosures, even if disclosures are that important. And finally, I'm almost done talking about intervention bias. And a lot of this I learned from my friend Andrew Foy at Penn State. So doctors have a bias towards action. And there's so many factors, right? There's magic bullets I talked about. We have this death denial. We have uncomfortable feelings about uncertainties. Fear. I didn't have time to show you my slides on how fear shreds decision-making. We have medicalization, where the society has been sort of convinced that they're sick and there's lurking diseases everywhere. And of course, there's the profit motive. And all this pushes doctors towards bias, towards action. And this is a large stimulus for why we wrote the case for being a medical conservative. And even though we quoted William Buckley Jr., we didn't mean to be political, but a medical conservative, someone who stands athwart history and says stop at a time when no one is inclined to do so, or have much patience with those who urge it. And I see myself saying stop with the AFib ablation so much, or stop with the Watchman procedures. And finally, the medical conservative adopts new therapies when the benefit is clear and the evidence strong and unbiased. And with that, I'll say thank you, and to remind everybody to stay skeptical. And Louis, thank you for having me.
Thank you, John. What a great talk. What a great talk. You were able to speak philosophically using our real world examples of cardiology. It was inspiring. Thank you very much. Now let's go to Bob Kaplan. Evidence for approval of the new drugs by the US FDA. Bob, it's up to you.
So let me see if I can get this. There we go. Do you see the slides on the screen?
Not yet. Okay, right now we see.
Good. Well, thank you very much. Thank you, Luis, and thank you, John. I have to say that John and I didn't coordinate these talks, but that so much of what I wanted to say you've already heard in John's talk. But let me just progress and tell you a little bit about what we've been thinking. Here's what I'm going to argue today. That I'm going to argue that there's a substantial mismatch between consumer expectation of the benefits of pharmaceutical products and health outcomes. And this occurs for a variety of reasons. First, there's a surrogate marker problem, which I'll talk about. There's the problem of efficacy versus effectiveness. There's the problem of selective reporting, which John mentioned, the problem of spin, which of course John has just covered, and then problems with hidden data. And the talk is based on some work I've been doing over the last couple of years, starting when I worked for the US federal government and then continuing at Stanford. Part of it involves a re-review of all the large randomized clinical trials funded by the US National Heart, Lung, and Blood Institute. And then a systematic review we've been doing of all new approvals of pharmaceutical products in the US. So I want to talk just a little bit about the US FDA, and I'm going to just go quickly, but to say that there's always been concern about the safety of foods and medications. And there's historical evidence that this goes all the way back to the 13th century. And in the United States, there actually was concern about the safety and the regulation of food products going back to colonial times. Federal controls of drug supply began with inspections of imported drugs in about the middle of the 19th century. And then the first laws concerning biologics go back actually a couple centuries. There have been some important milestones, which I'm just going to mention briefly. So the Food, Drug, and Cosmetics Act, which is still in place in the United States, was passed in 1938. By about 1951, there was the realization that pharmaceutical products could be dangerous, and legislation was passed to create the need for prescriptions so that pharmaceutical products could be obtained without prescription much more easily prior to the middle of the 20th century. But the Dunham-Humphrey Amendment to the Food, Drug, and Cosmetic Act required greater authorization through the use of prescriptions. And then following the thalidomide debacle, in about the middle of the 20th century, there was the realization that pharmaceutical products could be quite harmful. And for the first time, the FDA stepped up its standards for evidence for safety and efficacy. I'm not going to go through all of this in the timeline, but there always has been a tension between regulation and innovation. And so through the 1960s, 70s, and 80s, there was the very strong feeling that the FDA was acting with too strong of a hand, and that the public was missing out on the likelihood of innovation because of these tightened standards over safety and efficacy. And so following the HIV epidemic, there was a lot of concern about holding back medications which the public thought would be helpful. And there was a particularly influential paper that was an internal document at the FDA that was called Innovation or Stagnation. And this came out in about 2004. And in this report, it was argued that that we were sort of choking off innovation with a regulation that was too heavy-handed. And that had led to the 21st Century Cures Act, which was initiated it was passed by the US Congress at the very end of the Obama administration in 2016. And this actually represented years of tension and debate. But the 21st Century Cures Act was a response to this idea that regulation had been too heavy-handed. And so part of what happened as a function of the 21st Century Cures Act was there was instruction for relaxation of the evidence standards for new drug approvals. And I'm going to come back to that in just a little while. But that this actually brought us in a new direction that allowed a return to approvals based on surrogate markers, on relaxation of the requirement that products be approved on the basis of randomized clinical trials, so that they argued that there might be other methodologies that could be used as well. So I'm going to switch gears briefly to talk a little bit about evidence standards. Then I'm going to come back and try to tie these together. So when Luis mentioned that I've changed jobs a lot in the last few years. And one of those job changes required me to sort of get rid of a lot of the paper stuff I had. And, we're moving everything onto our hard disks now. So I'm sort of cleaning out my filing cabinets of old papers. And when I did that, I came across this really interesting paper, which is about 60 years old, by Archie Cochran and Austin Bradford Hill. And what they argue in this paper is that if we want to decide whether or not to use a medication, we have to address three questions. One is, can it work? The second question is, does it work? And the third question is it worth it? And so I want to go through these three criteria and then try to relate that to how we do drug approvals. So the first question is, can it work? Well, this is essentially thought of as a binary question. Can this medicine work or not? And when we think about the can it work question, it turns out that this is what motivates virtually all basic lab science, phase 1 human trials, phase 2 trials, and actually phase 3 trials as well. It's the scientific question that is studied under really almost ideal circumstances, where there's a lot of control all the way through phase 3 randomized clinical trials. And it gets at this basic narrative that John sort of hinted at, that the narrative is that there's a very smooth linear translation from bench to bedside. And here you see this picture of these two women in actually an advertisement from the Pharmaceutical Manufacturers Association, where the woman on one side is a laboratory scientist who's doing her work so that it will be translated to address the medical problem of the other woman who's a patient. And so I'd like to talk just a second about, well, how are we doing on the linear translation, the smooth translation from bench to bedside? Because this is the narrative that is so well appreciated by the public. When I worked at NIH, I had the opportunity to serve on two different committees. One was the internal NIH committee on replication, and then I also served on the same committee for the National Science Foundation, roughly the same year. And in those committees, we had an opportunity to look at all kinds of work that went from sort of basic lab science through clinical research. And one of the things that was very much a surprise to me, because I'm not a bench scientist, was the realization of how poor the reproducibility is of some of the most basic science. So, for example, if you look at cell lines become easily contaminated. And one of the things that came out of this was the realization that that guinea pig cells can masquerade as mouse cells, or ovarian cancer cells can later be found out to be breast cancer cells. And in fact, this is not rare. It occurs somewhere between 14 and 30% of all cell lines that are submitted for authentication by a third party. We also looked at animal studies, and that again, this idea of there being a very sort of smooth transition, that animal studies tell us a lot about human outcomes. One of the things that we looked at was a series of studies on ALS. And what happened is that there's an ALS foundation that that tries to replicate the results, and these are all animal studies, but these are evaluations of new therapeutics. And what you see here is the aqua-colored bars are what are published in literature, and then the black bars are the replication results that are done by this ALS group. And what you can see is that actually they replicated the animal studies in 0% of the cases, and in many of the cases that in fact that the results went in the opposite direction. We also looked at generalizability studies, and this is one of my favorite quotes. It says, "The best model for a cat is another cat, or preferably the same cat." And a good example of this came from one of my NIH colleagues, Robin Barr, who's the director of extramural research at the National Institutes of Aging. And one of the comments he made in a talk that I gave with him was, he said, "We've cured Alzheimer's disease 300 times in mouse models, but so far failed to cure it in any humans." And he was referring to a new meta-analysis that was published that year of 221 consecutive phase 3 placebo-controlled trials, all of which had failed to show that very promising therapeutics in Alzheimer's disease actually had positive results, leading to this extremely high attrition rate for these new drugs. So one of the comments that I wanted to make was about the use of surrogates, again, because the 21st Century Cures Act allowed for the return of approvals based on surrogate markers as opposed to what we consider to be legitimate health outcomes. And there are many, many examples of this, but I like to say that we look at mechanism because that we think that people are like cars. So the argument is that we can find a problem with our car and we can fix it. And we can do that by replacing a missing part or making an adjustment. But the problem is that cars are designed and manufactured by humans in factories, and that human beings are much more complicated with all kinds of complex interaction systems. So that if you achieve a good result on a surrogate marker, it doesn't necessarily mean you'll achieve a good result on the health outcome of great interest. And I have literally hundreds of examples of this, and so I'll just give you one, but suffice it to say that you can find literally hundreds and hundreds of such examples. So the example I'll give you today comes from the Accord trial, a big randomized clinical trial for people with type 2 diabetes. And the outcome of interest was death from cardiovascular disease and all-cause mortality. But here you see that people were randomly assigned to standard therapy or to intensive therapy. And you can see that those assigned to intensive therapy achieve significantly better outcomes on the surrogate marker, in this case, glycosylated hemoglobin. So we say that this problem has been fixed. But in fact, when you look at the outcome, so that in this case, all-cause mortality, not only was there not a benefit for intensive therapy, but in fact, deaths were significantly higher. We also make the assumption that good ideas from basic science eventually become pharmaceutical products. And I think that the public believes, and certainly with the pressure they put on the FDA, they have created this argument that we just have to let more products come through because there's so many promising ideas that come from the lab, and that if we just work them through, all of those or many of those will become successful pharmaceutical products. So just to remind you, if you look at the number of compounds or new molecular entities that have promise, and then we look at how many of those actually end up becoming licensed pharmaceutical products. We start with 10,000 compounds. And then of those 10,000, only about 250 make it to preclinical studies. And that's about 2.5%. So if you think about a one-tailed test, it's about as many as you would expect from chance. And then if you take those compounds that are evaluated in preclinical studies and take those that produce enough evidence that they make it to clinical trials, only about 5 of the 250 make it there. That's about 2%, or actually slightly less than you would expect by chance. But then there is a better transition. So among those that get to randomized clinical trials, about one of those becomes a licensed product. So out of the 10,000 initial compounds, only about one becomes a licensed product through this evaluative process. One of the things that we looked at when I was at NIH was how often do randomized clinical trials, and sort of phase 3, but also these are post-marketing trials, how often do they produce positive results? And this is, by the way, a study that was published a few years back, but also an updated version of it was published in the inaugural issue of Luis's evidence-based medicine journal. So we had the opportunity when I was at NIH to look at all the large randomized clinical trials that NIH has funded over the last 50 years. And when we looked at all of them, we realized that over half of them, about 60%, produced positive results. And those are the dark bars here. You know, of course, CAST, which John mentioned, it was considered somewhat of an outlier. But this was all the studies published before the year 2000. If we looked at those published after 2000, something remarkably happened. But let me sort of get at this issue of what happened around the year 2000. Well, in 1997, they passed the Fda Modernization Act, and that created transparent reporting standards. It initiated the clinicaltrials.gov service, where trials have to be prospectively registered. And starting in about 2000, NHLBI was the first of the NIH institutes that required all their trials to be registered, where they prospectively declared the primary outcome variable. And here's what happened. The number of positive trials actually fell off a cliff. It went from about 58% down to about 8%. So that's the can it work issue. Then there's the question of does it work? And the does it work question deals with this issue of efficacy versus effectiveness. So the efficacy versus effective problem deals with whether or not participants in large trials differ in systematic ways from patients seen in clinical care. In other words, are the participants representative of those who are seen in clinical practice? You might ask this question if you're a practicing clinician. Would you turn a patient away seeking care for high blood pressure if she also has diabetes? Or would you turn someone away who lives more than 6 miles from the medical center? Well, it turns out that most doctors in clinical practice don't have exclusion criteria. In other words, that if you're, if you're a cardiologist and someone comes in for care for cancer, you would refer them to an oncologist. And in fact, most people don't turn people away. Yet in randomized clinical trials, we know that people are systematically eliminated for these problems. So the SPRINT trial, extremely influential trial in the management of high blood pressure, excluded people with diabetes and so forth. And I have many, many examples of that. I'm going to skip this because I'm running late, but this is just an example of this. These are trials evaluating new therapeutics for Alzheimer's disease. And what you see here are the age distributions for people in these trials. But here's the median age for people who have Alzheimer's disease, have a new diagnosis of Alzheimer's disease. So what you see is that people in trials are systematically younger than people at their incident diagnosis age. And we have many, many, many examples of this, but this is just examples of people who are excluded from research on alcohol, tobacco, and illicit drug use. And these turn out to be common exclusion criteria in these studies: psychiatric disorder, medical disorder, compliance, motivation, social instability, which turn out to be highly associated with alcohol and drug use. And it was estimated that somewhere between 64 and 96% of potential participants were excluded. And then the other issue, which I will cover relatively quickly because that John did such a good job of this in his talk. But there is a problem which I consider to be the most severe one, which is this issue of what we call the hidden secrets, that so many data are hidden from public view because of publication bias, spin, and a variety of other problems. For example, the US FDA typically requires at least 2 trials for approval. But it's become common that drugs are approved on the basis of fewer trials. And in fact, that there are many more trials that we know have started where the results are never published or reported publicly. One of the most interesting examples of this was that there was an evaluation in Germany by the NICE-like organization in Germany, and they were interested in SSRIs for the treatment of depression. And that 2 trials were submitted for their review, but this review group realized or had heard that there were many more trials available to the manufacturer of this pharmaceutical product. And so they demanded that they see all the trials, and they said, and if we don't, then we won't allow this medication to be on our list for purchase. So here's what happened. This was an interesting paper in the BMJ. So these are the 2 trials that were put forward. And actually, these were the 2 trials that were also used in applications to the regulators. And they both produced positive results. But what you see in these other bars were all the other 10 trials that were part of this evaluation process that were never made public. There's the issue of spin, which John did a great job of describing, but it manifests itself in a variety of different ways. One of the most interesting papers is this issue of citation and reporting bias. So now that we have clinicaltrials.gov and we can look up all the different trials that were available, we can determine how many of the total pool of trials eventually were published. And so this is the publication bias. And what you see here is the total number of trials. And then the green bars are the ones, or the green dots are those that have positive results. The red ones are those that had null or negative results. And so that studies that have null or negative results are significantly less likely to get published. And then there's outcome reporting bias. These are sort of this selection of variables that get reported from a pool of outcome variables in studies. And so there's a smaller number. And then there's spin. So that what happens is the positive results tend to get reported and discussed, where the negative results are discussed less often. And then there's the problem of citation bias. In fact, we don't want to talk about null or negative trials, so that citations tend to go to the studies that produce more positive results. This is a study which John mentioned he is a co-author on, and he talked about this, so I'll just skip over it. But suffice it to say, as John mentioned, that that there is substantial spin, even in papers published in the very best journals. They focused on parallel group RCTs in the 6 highest impact journals. And quite remarkably, that 67% of those studies spun the results in the main portion of the study, and then 10% did in the title. So this gets us to the last issue: is it worth it? And I just wanted to mention that this issue gets at different types of analyses that deal with cost effectiveness and cost and so forth. And it's just worth saying that the US FDA is not allowed to consider cost when they evaluate new products. So I'd like to just turn to the final portion of my comments today to talk about the 21st Century Cures Act. Just mention that it did do some good things. It provided $6.3 billion new dollars for funding, mostly to the NIH. It funded mental health parity in the US, which is very important. And it didn't create any new taxes because they had a magical way of doing this by selling off strategic oil reserves in the US. But it might do some bad things. So, for example, it was promoted largely by people in the pharmaceutical industry. It was supported and promoted by 1,300 lobbyists. And it de-emphasizes randomized clinical trials, and it allows more preclinical data, including animal studies, surrogate markers, and clinical opinion to weigh in as components in the decision process for the approval of new medicines. So here's what happened. The act was passed in 1996. There was a phase-in year in 2017, and then the full implementation started in about 2018. And so what you see is the number of new approvals the year before the act was passed. And then the next year, when it was phasing in, they doubled. And then by 2018, they tripled. And that's been fairly constant since then. And I just want to give you just one interesting example, just to give you a sense of how products, in our opinion, are getting approved that we think are unlikely to have been approved in the past. So this is the example of a new study for a condition called female hyposexual desire disorder. And female hyposexual desire disorder is essentially women who lose interest in sex, premenopausal women. And here's the outcome in randomized clinical trials. So women were randomly assigned. It was based on approved on the basis of 2 trials. So they're randomly assigned to this medication or to placebo. And the outcome variable was change in sexual desire on a scale from 0 to 6. And it went from 2.2 to 2.4 in this one trial, and a little bit less in the other trial. And the absolute risk change is minuscule, but there are side effects. And so it turns out that among women that were taking this medication, 22% of them experienced serious nausea, and this was only about 3% in the placebo group. And this is not a pill. You have to inject it. And it requires an auto-injection 45 minutes prior to sexual activity, and it costs about $899 out of pocket per month. And here's the ad that came out. It says, "Give her the power to call the shots," quite literally. So it's just a way of winding this down. Over the last few years, we've been evaluating and reevaluating every new FDA approval. And so we can look at the number of results reported, the number of completed active completed trials, and the number of studies listed for each of these drugs. So we get all of the data from this from clinicaltrials.gov. And what we find is that on average, most of these products were under investigation in about an average of about 14 studies. And of those, about 6 to 7 of the studies were completed. But the results that are reported in clinicaltrials.gov is less than half of the completed. We've looked at, over the course of years, the number of trials listed in approvals. And so if you go back to 2016, the blue bars, the modal number of trials that serve as the basis for a new approval was about 32%. Now it's gone down. I'm sorry. The mode was to have 3 trials used in the approval. Now, actually, many more trials are based. The mode is actually approval on a single trial. We also know that if you look at the number of trials in clinicaltrials.gov, which should have been completed and should have reported results, is less than half as what would have been expected. And we think this is a very serious problem. This is from a New England Journal paper, but our results are almost identical, and ours go into 2019. So let me just make one final comment and say that what's happening right now? Well, as many of you know, we have an election coming up in the US, and our President Trump, says that a vaccine for the coronavirus will be available or will be approved prior to the November 3rd election. But there's no phase 3 clinical trial. Several of them are in play, but none of those trials will be completed by that date, unless there's some very unexpected early endpoint to one of the trials. Yesterday, the Trump administration announced that there's going to be a special FDA review for emergency use authorization that has been now scheduled for October 22nd. So by way of summary, this is why I think that consumers are disadvantaged. First, direct-to-consumer advertising has become the main source of information for many consumers in the US. And of course, that overstates benefits and understates harms. And that most of the studies that we use, particularly for communication with the public, are based on the can it work question. There is an efficacy effectiveness gap. And so we think that much more of the concentration should be on the does it work and the is it worth question. And the elephant in the room is that much of the information, in fact, we think most of the information, is hidden from public view because of publication bias, selective reporting, and spin. So I think I'll just skip this and say, thanks so much for having me. Luis, thanks for putting this together. And John, thanks for a wonderful talk. I learned a tremendous amount from it.
Thank you, Bob, for just such an inspiring presentation. Many points. I think you were able to put so much experience of your previous work in a single lecture. So thank you very much. We have a sense that we kind of lived, experience your past experience in the NIH and during your talk, listen to your talk, we have this sense that we also had this experience together with you. So I'll start talking about asking questions for you both so we can start a discussion. And I think John can start appearing here, George. Put John on the screen too. Okay. So I think we have a problem with priors or prior belief. Sometimes our priors are too high that even a spin is able to provide a good positive predictive value of the study. So I think that the first bias is our ability to believe more than to be skeptical. The conclusion of John was great, that be skeptical, right? So I've been talking about, for example, so many trials testing hydroxychloroquine against placebo. And I've said that there should be no trial because people who believe, they have such a great belief. The prior is too high that no negative trial will be able to have a good negative predictive value. So science is not to improve things, it's to prove something that has some reasonable pretest probability. So I think we have this problem with, I mean, faith might be good for human being. Faith is a good mindset in some terms, but not professionally or deciding what to prescribe or not. Then professionally, you have to use more like a scientific or skeptical view. So do you think, in thinking about solution, and I think the world, I have an optimist view. I think we are evolving. I don't think we are in a crisis. This type of discussion here was not so frequent before. So we are getting better. Like Paul McCartney has a music getting better all the time. I'm like that music. I think we get better, but we're not at that good point yet. So I think we have discussed how to better establish our priors. This problem with high priors is more like a human trait, or there's much conflict of interest putting these priors higher than it should be. Is it more like a psychological thing or cognitive thing we should work on, or we should be aware of conflict of interest in industry and monetary interests? I know both are part, but what should be the first step in terms of making society change regarding this?
Bob?
Well, first of all, it's a really good question, and I'll sort of turn it back to the two of you in cardiology. You know, there are these issues like PCI, for example, which Courage and I can't actually remember that David Marin's trial that
Ischemia.
Ischemia, yeah. So that that my impression is that it has been very hard to change the priors of many practicing cardiologists. That there are procedures that make tremendous logical sense and sometimes aren't supported by the data, and that how that eventually affects practice, I think, is quite a challenge. But I'd be interested in hearing your reaction to that.
Yeah, so Louis, I really appreciate the comment, because really my career changed about 8 years ago when Vinay's paper first came out. I wrote about it in our local medical journal, and one of our pulmonologists, Dr. Lloyd, John Lloyd, he's retired, but he was this epic figure, just beloved and the smartest man, and always wore a suit and tie. And he sat me down in a doctor's lounge. And he says, John, you wrote a nice paper, but we really don't control outcomes. And I said, well, what do you mean, Dr. Lloyd? I'm a cardiologist. Of course I control outcomes. I mean, we have tools. And he told the story of two patients with sepsis that he was treating. And one patient, they're both very sick. And he expected one patient to really do poorly. He didn't think he would survive. He treated him with a protocol. Next morning, the fellow was up eating breakfast, doing fine. Very similar patient, treated in the same way. A couple of days later, thought he was going to live, and learned that he had died that night. And so it really struck me about how much we control outcomes. And it was a seminal moment, because if you constantly believe that you control everything, then you're just going to have this action bias. But if you can believe that we have some effect and we can be a good doctor and do the best we can, but a lot of it's out of our control, then I think, it really helps. But it's a very hard thing. It's a very hard thing to consider. Another example is, you do an AFib ablation on someone and they come back and they don't have AFib. But then there are also patients who have tons of AFib, and you don't do anything. They refuse to have an AFib ablation, and they come back and their AFib is gone. And so you wonder whether it just, people get better despite us. And so I just think we should have these thoughts in our head. We should be talking to ourselves about it. But yeah, anyways, it's a.
So I think nature is much more powerful than our decision in medicine, right? And then we go. I mean, your answer there goes to the another bias, that is our certainty bias, or uncertainty aversion, right? And I think the next step of medical cognition will be to embrace uncertainty as the most important tool. It's not accepting uncertainty, it's embracing uncertainty as the most important tool in medical decision. Because when you embrace uncertainty, you start thinking about probabilities and how much change a probability. And if you look at, let's say, ACE inhibitor for heart failure, it's like 4% chance to provide a beneficial effect to a patient, 4 or 5% chance. I mean, 5% is the absolute risk reduction that we think is too good because it provides an NNT of 20, but it's a 5% chance. You have to give medication to 100 people for 5 to get the beneficial effect of. So we must be humble. The NNT that you mentioned in your talk bring us a sense of humbleness that we need as a physician to make good decisions. And if you are humble, we can accept uncertainty as that's the main way to think. So, I mean, it's not accepting uncertainty, it's using uncertainty as the start of the thinking, and then finish with probability. Another thing that I want to discuss with you is the economical think, and I don't mean economical in the monetary way, but in terms of balancing cost and beneficial effect. And so physicians and people in general tend to overestimate the effects, underestimate the cost. And those who pay the cost are the patients. We don't pay the cost. So it's the skin in the game, like Taleb says, right? We don't have our skin in the game. It's the patients, but we take the decision underestimating the harm. So, and another thing is we overestimate. The beneficial effect. So, like for example, cancer screening. Like Bob, I've seen Bob's talk in Germany about breast cancer screening, and I don't think the discussion should be if it reduces or not mortality. It should be how much it reduces mortality, and compare this with the harm, because probably it reduces some. I know some trials are negative, some trials are positive, but it is like a parachute that some people will get some beneficial effect. So it's like a parachute. So it's not a matter of yes or no. It's a matter of how much in comparison of the harm. So what do you think? How to solve this? I call this anti-economical bias. I mean, Richard Thaler won the Nobel Prize for this idea that we are anti-economic in monetary ways, in medical ways, whatever. So how to solve this? How to put an economical way of thinking in the minds of the society and of the physician? But
well, first of all, it's a very challenging question, and that because the resources are limited, and that we can't do everything, and so we have to use the resources to produce the most health for the most people. And that is actually the traditional economic way of thinking about it. And that I do think that it connects to your first question about cognitive biases, that there may be an expectation that the treatment works every time, or that somebody, if they're going to get their colonoscopy, then the assumption is that they're protected, and that they won't they won't experience colorectal cancer or adverse outcomes from colorectal cancer. Where in fact, for the average 50-year-old, I looked at the numbers recently. I think that you change your probability of death from colorectal cancer from, an absolute risk of 2% to 1.3% or something, and maybe 1% under the best circumstances. And so, and that's one of the best cancer screening tests that we have. And so that there is this relationship between effect size that, when things are presented in relative risk as opposed to absolute risk numbers, that people are, I think, deliberately misled. Even though, I get my colonoscopies, I mean, I believe in screening tests, but that the expected effect is much greater than the real absolute risk change.
Louis, I think it gets back to your idea of the priors, and we think we have control, right? So colonoscopy is okay. So let's say there's a neutral effect on overall mortality, or let's say it's just a little bit better, and it reduces the risk of dying for colorectal cancer. And let's assume you don't have a family history and you're just a normal person. I mean, why do doctors think they work in a hospital? Why do people think that screening for one disease that can kill you of thousands, why do they think that's a valuable thing to do? It just seems to me it's just a height of hubris to think that we can prevent ourselves from dying from screening for one of the zillion things that can kill you. I mean, my wife is a hospice and palliative care physician, and I mean, she just has stories after stories of people who just have things happen to them. And if you don't believe that, if you believe that there's greater outside control and that you can't control everything, then it almost gives people a freedom not to worry about that. And I just think that it gets to regret and control, and I just don't think we have that much control. So,
just a quick comment on that. When I was at the Agency for Healthcare Research and Quality, that we oversaw the U.S. Preventive Services Task Force. So HRQ does the administrative work. We got the evidence-based reviews done and all that stuff, but we weren't task force members. But as chief science officer, I got to sit in on all the meetings and watch them debate about things. And John, it kind of gets at this issue. How do they select things? There's a process, and it turns out I am very much a believer in their process. I like what they do. But there are some quite heated discussions. And, it gets back to the first issue that we discussed about, how do people come to the beliefs they have? And I was going to ask you guys about this. So one of the issues that came up, they started the study when I was there, and it was completed after I was there, but it dealt with screening for coronary calcium, which was a very hot thing. And that, so the one side of the argument is, well, here's something that's a pretty good predictor of outcome. And the other side of it is, but we don't really know that we can do anything to change that trajectory. And it got pretty heated. And that I know the ACC and AHA came out with a completely different recommendation than the USPSTF. And I was curious about, how you think, they're looking at the same evidence, the same studies, right? Why they came to such different conclusions.
So as an imaging guy, I used to read CT scans for coronaries, and I mean, it's like a tribe of imaging people thinking that thing is like God, predicting what will happen and avoiding events. But if we see the incremental value of calcium scoring over Framingham is tiny. It is an independent predictor, but incremental value is tiny. Then there is a second question. If the incremental value was good, would you do something different to prevent events? No, we do what we do. We control hypertension. If cholesterol is too high, we control cholesterol. We wouldn't be doing so much to add so much. So it's very difficult to understand why there is so much faith in something that is not probable. It's improbable to work, but the prior is too high. So I had also had this hot discussion because I was supposed to be defending it because I'm part of this field, but it is an interesting issue. Then I have an opinion about this, about the solution. I think we can't have evidence-based medicine if we don't have an evidence-based society. It's not only medicine that is not evidence-based, it's everything is not evidence-based medicine. Oh, I mean, evidence-based. So maybe we should start by teaching what is the scientific thinking. What about thinking scientifically? Not necessarily teaching in school, but finding a way to make it part of our culture. I think this is the way a society will evolve. And then when we have an evidence-based society, we will have evidence-based medicine. Because recently we had the discussion in our school how to teach evidence-based medicine. People said the medical schools are guilt because are not teaching evidence-based medicine. I said, we should teach. But it's not medical school, it's the residency too. It's the society, it's the physician, it's how we go to mainstream journalism and give interviews. So we must educate the society, I think, about probabilistic, about uncertainty, economical thinking. So you've been talking in your lectures, you gave a lot of examples about publications, okay? And I'd like to talk a little bit about the scientific ecosystem of publications. So I'll invite now our executive editor of our Journal of Evidence-Based Healthcare Evidence. His name is João Ribeiro, and he will appear here. And so this is, where is João? This is João. And he is our executive editor of Evidence, our Journal of Evidence-Based Healthcare. You both are international editors of this journal, and you both published in this journal. And this is our executive editor. He's a information scientist, and has a question for you regarding this scientific ecosystem. João.
Hello, happy to be here, and awesome talks you gave. So thank you. We have been talking a lot about faith in science, and should we be pressing for faith in science or for skills to develop skepticism, perhaps? And if so, how do we teach organize purposeful, reasonable skepticism, not just to society, that's pretty much a given, but also to scientists? That would be the first question. And the second would be that it would appear that some scientists, they have difficulty writing transparent papers, intentionally or not. We're not gonna get into that. And not just journalists, they have issues on interpreting papers and not falling for spins. How should we approach bridging that gap? These are my two questions. Thanks.
Bridging the gap of the way authors write?
Journalists and society and scientists.
Oh, okay. Bridging the gap between journalism and scientific writing. Okay.
Yeah, these three stakeholders, the three players.
Okay.
So I think that they should start by listening to John's lecture. That was that I think that is very important. That because I am concerned about this issue. That we have the issue of evidence-based medicine and eminence-based medicine, and you hear so much of it now that in the U.S. there's an advisor to President Trump who is a radiologist by background, and he says a lot of things I disagree with. But the way that journalists deal with it is they say, "Oh well, he shouldn't be allowed to talk about this. He's a radiologist. He's not an infectious disease doctor." And so they discredit him not based on where his evidence comes from, but who he is. And you hear a lot about this. And again, I think that that what we need to do is to do a better job of getting people to think like John does, to think analytically, to be able to interpret evidence and so forth, including a lot of practicing physicians that I work with that are really completely confused by positive predictive values, negative predictive values, and so forth. And this issue, I mean, it comes up with coronavirus testing. You have reasonable sensitivity and and good specificity, but an extremely low prevalence rate, and that really messes up the how the tests are interpreted. And it turns out that's very hard to explain to people, and it's extremely hard to explain to journalists. Anyway.
Yeah, I think there's I think there's my first reaction is there just should be way more humility in science. I mean, Popper talked about it, and it's yeah. So that's the first thing, and I believe that journals should really lead in the abstract. One of the first things in the abstract of a journal should be the limitations of the study. But the problem, and every study has limitations. Every study is flawed. It's not personal to point out these limitations. And so if we could get used to that, that would help. The problem is, at least in the US, I don't know how it is in Brazil, but here science has become politicized. And so if you become skeptical of science, that's the right way to be, but then it can actually backfire. So I'm an optimist like you, Luis. I believe that if we keep talking about what science can and can't do, I think it's just going to be a good thing. But it's going to be a process. And I guess I would also add for the people, the true evidence-based medicine. I mean, what Sackett really talked about was the best use of the best evidence we had combined with clinical judgment and patient value. And so it isn't just rote interpretation of clinical trials. It's applying those, like Bob talked about, this external validity issue about how to generalize a trial. And I just think all those are important, and we just need to keep doing this more and more. I'm actually an optimist about social media because it allows people like us to have a voice and people to talk about these limitations.
What I see in social media, Twitter, is nowadays, if you publish a bad article, you're going to be ashamed. Even if it's published in a good journal, with Twitter now, the person will be ridicularized. And before, it didn't happen.
No, but see, that's what we have to get over because, okay, I'll tell you an example. We published a paper on fragility index, which I personally like because it's a little bit.
I like this paper.
But anyways, my friends and my statisticians friends just destroyed it. But I mean, I liked being destroyed. It didn't bother me. I mean, it's just, it didn't take it personally.
Let me go to, I mentioned the tribe of, cardiologists, but there is also a tribe of people who defend science. I don't like the word, the expression defending science as if it was like a war. I don't like this. I think we should talk about science more. But there is a tribe of, evidence-based medicine and, scientific integrity too. And I will quote the very article. I like that article too, the Brian Nosek article about reproducibility of statistical analysis. But I wrote a piece at that time. I don't know if I share with you, but actually, I would make the opposite conclusion with that article because I know there was some disagreement in a binary fashion. Right. But the odds ratio is much more agreeable than disagreeable. You know what I mean? So I read that paper and I said, wow, using different methods, they kind of numerically, they kind of got the very same results.
Right.
So, I interpreted that there was some kind of bias in that conclusion. People from our field of critical appraisal, we like to criticize But sometimes we ourselves have our bias. So in our meta science group, and João is part of this group, we started discussing with the students meta science articles, and we got a sense that there's a lot of methodological problems in the article, in the meta science articles, and the conclusions that we also do spin with meta science.
So, Luis, maybe a little bit of a tangent to this discussion, but one of the things I've been thinking a lot about lately is the realization that the publishing process is broken. And I think that what's happened with the current pandemic has highlighted that. So, as John pointed out, there are these big problems with publication bias. So if you look at what's published in the New England Journal of Medicine, it's very atypical, actually. The rejection rate is 95 or higher %. And so that it's the very rare article that gets published. And that now, we have these preprint servers and so forth where people can post their work. And that maybe that would provide a more representative sample of studies. And they're never going to be bulletproof and perfect, but we would know a little bit more about what's going on. And we see this in our review of all the stuff, all the trials listed in clinicaltrials.gov, and how few of them even report results. And then when you can actually get into the data, as we did in the NHLBI study, you realize that studies are much less likely to ever see the light of day if they have a confusing finding. So, and the other point I wanted to make about that is that publishing is a big profitable industry, and that here in California, the University of California decided to not subscribe to Elsevier journals any longer because that they were charging too much, and that here's this multi-billion-dollar corporation, and it's making profit because it's all based on essentially unpaid labor of literally hundreds of thousands of hours of reviewer time. And that maybe the university should take back the publishing process. Maybe we should have a broader representation of all studies that are completed that become public and so forth. So anyway, I'm starting to think a little bit about this, but I become increasingly convinced that there's something wrong with the way we've been doing things.
The preprint server thing cuts both ways, doesn't it? Boy, before the pandemic, I was just all over this. I thought this was a brilliant idea and loved it. But there has been, like anything, benefits and harms. And I think publishing dubious studies and then not having a critical review of it can be problematic. So I guess it is what it is.
So should we read a preprint and change our prescription according to a preprint, John?
Well, no. I mean,
discussing this.
Yeah, I mean, I think we just have to be. I think we have to be really, really careful, just as we are. But I agree with the publishing process is super problematic.
So I'll ask the other John. João is John in Portuguese, right? So I'll ask the other John. Is the peer review process, in your opinion, does the peer review process improve the quality of the publication?
That's tricky, right? We're both editors. We don't have evidence that peer review actually does improve the quality. The small evidence we managed to gather is that it improves a little bit, around like less than 5%, the overall quality of the paper. So we can actually do a systematic review on the evidence, because all evidence available is either computational models, it's modeling, it's not like real world stuff. And there's actually a e-print by initiative called Brazilian Reproducibility Initiative by Olavo Moral, which found that it's the only empirical evidence that we have so far that I know of, it found that it's only around less than 5% of increase if you compare. They use the control group. So if you compare study designs, it's about that. So besides publication bias and confirmation bias and all those biases from the Oxford collection of biases, we also have that peer review doesn't work, and we take it as a granted. And it's not even that old. It's not over 50 years or so.
It's not a solution. I agree. It doesn't improve too much, but it's important to be there. So maybe by knowing that there is a peer review, people will improve themselves by themselves, improve the article that will be submitted, right? So it's kind of important to know there will be a policeman in the corner if I do something wrong. I don't know if it decreases violence, but by knowing that, I think that's the importance of peer review. I mean, we only have 5 minutes now. I don't want to get too long. It's been so good, this discussion. We could stay for the entire day here. I like the last slide of Bob, that there are questions. So we don't pretend to give all answers, but to, make people think about stuff. I like one slide of Bob that he asked, is it really innovation? I know a difference between innovation and invention. And I have the sense that much of the things are invention. Innovation is the invention that makes a difference. So we must innovate medicine and innovate in the way of thinking. I think that's the real innovation. So I have to say thank you for you guys being here discussing with us. And I want to give a couple of minutes to each of you to give your final message and then to close. Bob.
Well, first of all, thanks for having me. That I do think this is a very important issue, and that as John said, we need to be good skeptics, and we need to be optimists and skeptics simultaneously, and to require the best evidence. And that one of the issues that I keep coming back to is the realization that so much of the information is not made public, and that there's this great comment. If it's in the public interest, it should be in the public domain. And I do think that we need much more emphasis on that, maybe tethered to better training to help practicing doctors and the general public understand how evidence should be interpreted and used.
John.
Louis, first of all, it's a real pleasure to see you and be with you. I surely wished it was in person in Brazil. But anyways, I guess I would leave with the message that what we do in medicine is just a beautiful thing. It's wonderful. We help people. And it's I love being a doctor, and I love evidence. And I think that taking a skeptical view is not the same as a cynical view. And I wouldn't go that far. I would just say to be, one of the biggest dangers that we have as clinicians is overconfidence and hubris. And if just being critical of the literature and being critical of the evidence and how much we can do just helps us avoid that overconfidence, but yet we still can help people in many different ways. And so I would just leave that as my final comment. And really it's been a pleasure. Thank you.
Thank you very much. So we'll be optimists. We are evolving. And there are so many comments here, and important comments and in the chat. And I invite everybody to read those comments, because it's like a very important property of ours now, this discussion. It was not only among us here that are appearing in the screen. I've been reading all these comments, and I took some of them to make my questions. But because of the time, we started a little later than planned. So because of the time, I'm not be able to ask the questions that were put here. But it's good to have the questions, because a good scientist is the one who gives more value to the questions that to the answers. So I'll finish now. I thank you all for participating, and that's the way we get close together. Yesterday, John said, it's so good to travel and to be in the site and to know people. We'll get back to that, and I hope that soon we invite you personally to our institution. Okay, so thank you, João Ribeiro, João Mandrola, and Bob Kaplan, and everybody that is here. Thank you, our professors, our directors of the program, everybody. I didn't mention any names because I didn't want to forget any. But I know everybody is here watching, and I just thank you very much. I'm very happy with this event. Okay?
Thank you.
Bye-bye.
Bye-bye.